Welcome to our course, Neural Network, and in this part of our course, we're going to talk more about hidden layers and how to make our neural network more complex as opposed to what we had in the past lesson because we just talked about only one layer. Adding one layer to another layer makes our neural network more complicated because neural networks become deep when they have two or more hidden layers. So for example, we have here an input, and anyway, input is actually a number that does not change because this is actually coming from the data. These are the features coming from the real observations. It can be from the sales, it can be from any data about demographics. From that input, the data is, or the information is flowed into the hidden layer 1 and then hidden layer 2. So these hidden layers actually make some kind of computations for a scientist, for an analyst, or for any person to be able to understand the insight coming from that data. These layers between the input and the output, they are called hidden layers. So in our figures, there's actually no output, but let's just imagine that after hidden layer 2 is our output. So these are called hidden layers because these layers are not actually directly observed, but in fact, they cannot be seen. These numbers are not present in the features of your data. But they are actually very, very important because they serve as an intermediary connections between your input and the output so that your data will be manipulated, it will be transformed for you to be able to get a very meaningful insight coming from your raw data. In a way, hidden layers make complex computations by applying different weights and even biases to your input data. This enables the network to model very intricate hidden layers. So how does this work using Python? Now we're going to have that. So here we are in our Python codes that I have already prepared for us to properly and easily manipulate our data. So first of all, we're going to need here NumPy for our computation. So we first input NumPy in here. And then supposing we have these inputs, 1, 2.1, 3.6, and so on. And as you can see, we have here different values. We have one group, the second group, and the third group. 1, 2, 3, 4. So for each input, we actually have 4 features. And what these features, that is something that we don't know. I have not actually labeled that, but for the purpose of this discussion and this demonstration, let's just think that these are the inputs to be given to our model, to our layers. So each input is mapped into a certain weight. So for example, 1 is mapped into 0.6, 2.1 is 0.9, and so on and so forth. Now for the biases, we use here 1, 2, 3, 3 biases, and these biases would actually help us better understand and better manipulate the kind of data that we have for us to be able to get a very meaningful data. So now that we have set our inputs and our weights and our biases, now let's execute this one. As you can see, we only have one group of inputs and we only have one group of weights. Now, having only one group of weight, we say here one group because this is considered one group. As you can see, this is just in one matrix. What we have in here is just only one layer. What we want to do now is to make our neural network deep. And so we want to add one more weights, one group of weights. So here we have added these weights, negative 0.2 and so on and so forth. And also we have added another group of biases and we call that biases number 2. And so just imagine that as having layers and then we add up one layer or the second layer to the first layer. So let's execute this one. And now we are now going to make the computation. So np dot inputs, np dot array weights. Now we have the transform, then plus the biases. This is for layer 1 outputs. Layer 2 outputs, we have the same computation, but only that of course we have added biases to weights number 2. So let's execute this one. Now, we are going to see our outputs for both layer 1 and layer 2. So as you can see, we have here the different outputs for both layer 1 and layer 2. And so having this kind of function, we would be able to get also the same output. So every time we have this kind of code, we always use function to properly manipulate and to also practice that particular computation to arrive at a certain output or to arrive to a certain outputs. So let's execute this one. So for each layer, we have these two. Maybe you would ask me that for each neural network model, because in this case, actually, we only have one model, there must be only one output, all right? So that means we're going to add up the result of one, and we're going to also add the result of two, so that we would be able to arrive at only one output. So more lessons about how we're going to manipulate and add up hidden layer 1 to hidden layer 2 would be our discussion in the future.
Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.